June 7, 1942, Point Luck, 150 miles northeast of Midway Atoll. Commander Yahachi Tanabe stood on the bridge of submarine defied 168, watching through his periscope as the crippled American carrier wallowed in the Pacific swells. USS Yorktown, designation CV-5, listed 7 degrees to port but remained stubbornly afloat. For 30 hours, the carrier had defied every expectation of naval architecture that Tanabe had learned during his 20-year career in the Imperial Japanese Navy. The ship should have been at the bottom of the ocean. Instead, American damage control teams worked across its deck with a methodical efficiency that seemed almost supernatural. Tanabe adjusted his periscope magnification, studying the organized chaos of repair operations. Fire hoses snaked across buckled flight deck plates. Welding torches cast brilliant flares against the grey morning sky. Pumps discharged thousands of gallons of seawater in cascading waterfalls down the carrier's hull. The Americans were not abandoning their ship. They were saving it. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Tanabe felt a peculiar mixture of professional admiration and tactical opportunity. He had studied American naval designs in war college, but seeing one endure this kind of punishment in real combat conditions felt like witnessing a new kind of warfare. Yorktown had taken bomb hits, torpedoes, and near-fatal fires, yet she refused to die. His instructors had always emphasized that a carrier's true vulnerability lay in her heart, her aviation fuel, her magazines, her open hangar decks. But here was a ship that had been struck in those very places and still survived. No doctrine he had learned could account for this. He thought of his own submariners, disciplined, brave, and dedicated, but lacking the kind of repair teams now fighting for Yorktown's life. Japanese naval tradition honored valor and precision, but damage control was never treated as a strategic discipline. Fire suppression was reactive, not preventative. Crews trained to fight the enemy, not the ship's wounds. Yorktown's crew, however, seemed to fight both with equal determination. Through the periscope, Tanabe watched as teams sealed compartments and rerouted electrical lines like surgeons stabilizing a wounded giant. Officers stood shoulder to shoulder with enlisted men, directing efforts, hauling equipment, passing hoses. Every sailor seemed to know exactly what to do, and more importantly, why it needed doing. This was not merely training. This was doctrine, cultural, technical, and deeply ingrained. A junior officer approached Tanabe on the conning tower. "Sir, should we prepare torpedoes? She may sink without intervention." Tanabe did not lower the periscope. He observed a repair crew forming a bucket line to pers, clear debris, another patching ruptured bulkheads, and a third adjusting pumps. "No," he replied quietly. "She will not sink without intervention." It was not an emotional judgment, it was an analytical one. He considered the strategic implications. If Yorktown could be saved, even after devastating damage, what did that mean for the war ahead? Japan's carrier fleet had struck with tactical brilliance at Pearl Harbor, Darwin, Colombo, and in the Indian Ocean. Their doctrine celebrated offense, boldness, and speed. But the Americans, though initially reactive, were proving something unsettling. They knew how to preserve their strength. In warfare, the ability to survive was as powerful as the ability to strike. He remembered something an American naval architect had reportedly said before the war. A carrier is not just a weapon, it is an organism. It must have the means to heal itself. At the time, Japanese officers dismissed such talk as philosophical nonsense. A ship was a tool, not a living thing. But now, as Yorktown fought for life against the sea itself, Tanabe finally understood. For 20 hours after the initial damage, Yorktown had continued flight operations while battling fires. For 30 hours after being declared unsalvageable, she had been rallied back from the brink. And now, even in her crippled state, she remained afloat, buoyant not just by design, but by will. Yet will could not change the fact that she was vulnerable. Tanabe lowered the periscope and gave the order to load torpedoes. The attack was executed with precision. Two torpedoes struck Yorktown, one beneath the island structure, the other near the funnel. The ship shuddered, rolled slightly to starboard, and her listing increased sharply. But even after being struck again lethally this time, she did not sink quickly. The Americans fought back, not with guns, but with pumps, hoses, axes, and steel plates. Their battle was not against Japanese submarines, it was against time, the ocean, and physics itself. Only after another day did Yorktown finally succumb, rolling slowly onto her port side, surrendering at last to the quiet pull of gravity and the sea. Even then, she went down gracefully, her colours still flying. Commander Tanabe did not cheer. He knew what the sinking of Yorktown meant. He had defeated a ship, but not what that ship represented. The Americans would build more carriers, improve their designs, refine their doctrines, and train their crews even further. Yorktown's survival, however temporary, had proven something vital: that American carriers were not merely platforms for launching planes. They were resilient instruments of sustained naval power. In the years that followed, 3 of them fought across thousands of miles of Pacific water. The Imperial Japanese Navy would lose carriers not because they were struck, but because they could not recover. Fires that might have been contained became infernos. Flooding that might have been controlled turned fatal. Ships that might have been saved were abandoned. And each time it happened, somewhere in the back of every naval officer's mind, the image of Yorktown would return, wounded, listing, on fire yet still alive. A ship not built merely to fight, but built to survive. 3 days earlier, Vice Admiral Chuichi Nagumo's carrier strike force had landed devastating hits on Yorktown during the Battle of Midway. Lieutenant Commander Takashige Egusa, Japan's finest dive bomber pilot, had personally led the attack that penetrated the carrier's flight deck with 3 direct bomb hits. Japanese pilots returning to their carriers had reported massive fires, catastrophic explosions, and structural damage that no warship could survive. Intelligence officers had confidently marked Yorktown as sunk in their after-action reports. Yet here the carrier remained, dead in the water but very much afloat, protected by a destroyer screen and actively conducting repairs. Tanabe had spent decades studying naval architecture at the Imperial Japanese Naval Academy. He understood ship construction, damage assessment, and the limits of what vessels could endure. Yorktown had absorbed punishment that should have sent it to the bottom within hours. Instead, American damage control teams had somehow contained fires, stabilized flooding, and restored partial power systems. The carrier represented a puzzle that challenged fundamental assumptions about naval warfare. When Tanabe's torpedoes finally found their mark on June 6th, sending 2 Type 95 weapons into Yorktown's port side, he had expected the carrier to capsize within minutes. Ships with 7-degree lists and massive internal damage did not survive additional torpedo impacts. Yet Yorktown had remained afloat for another 12 hours, finally rolling over and sinking only after destroyer Hammond, secured alongside for salvage operations, had absorbed a torpedo that detonated directly beneath both ships. The intelligence reports that reached Tokyo in the battle's aftermath painted an increasingly disturbing picture. American carriers possessed damage control capabilities that exceeded anything in Japanese naval experience. Ships that should have been destroyed returned to Pearl Harbor for repairs. Crews that should have abandoned burning wrecks instead fought fires and restored combat systems. Most troubling of all, the Americans seemed to treat catastrophic damage as a temporary inconvenience rather than a death sentence. Captain Toshio Abe, chief of the Naval Technical Department's Damage Control Section, received preliminary reports about Yorktown's survival with profound skepticism. The described timeline seemed impossible. Yorktown had taken 3 bomb hits that penetrated its flight deck, started massive fires, killed dozens of crew members, and disabled all power systems. Japanese carriers struck by similar damage at Midway, Akagi, Kaga, Soryu, had been abandoned and scuttled within hours. Yet American sources confirmed that Yorktown had not only survived the initial attack, but had restored enough capability to recover aircraft before the subsequent torpedo strike. Intelligence analysts at the Combined Fleet headquarters in Tokyo assembled detailed accounts from Japanese pilots who had observed Yorktown's condition after the bombing attacks. The reports described a ship wreathed in smoke, listing noticeably, with visible flight deck damage that suggested catastrophic internal destruction. Multiple pilots had witnessed secondary explosions that indicated magazine detonations or aviation fuel ignition. By every measure of naval damage assessment, the carrier should have been sinking or already sunk. American radio intercepts told a different story. Damage control reports transmitted between ships revealed that Yorktown's crew had extinguished all fires within 2 hours of the initial attack. Engineering teams had restored partial propulsion capability, allowing the carrier to steam at speeds approaching 20 knots. Flight operations had resumed, with aircraft landing and launching from sections of the flight deck that Japanese observers had reported as destroyed. The disconnect between expected outcomes and observed reality suggested fundamental differences in damage control philosophy that Japanese naval architects had never encountered. Abe authorized a comprehensive investigation into American damage control practices, drawing on intelligence gathered from captured documents, prisoner interrogations, and technical assessments of damaged American vessels that had been examined at captured facilities. The resulting analysis would consume 6 months of intensive research and ultimately reveal systematic advantages in training, equipment, materials, science, and organizational doctrine that Japanese shipbuilders had never considered implementing. The investigation began with structural analysis of American carrier design philosophy. Japanese naval architects had prioritized offensive capability, creating carriers with large hangar decks, extensive aviation fuel storage, and minimal internal compartmentalization that might interfere with aircraft handling efficiency. This approach maximized striking power but created vulnerabilities that became catastrophically apparent during combat damage scenarios. American carriers employed radically different design principles. Yorktown-class vessels featured hundreds of watertight compartments separated by steel bulkheads, capable of containing flooding and isolating fire damage. Redundant systems provided backup electrical power, multiple pumping stations, and parallel piping networks that allowed critical functions to continue even after severe damage. The design philosophy accepted weight penalties and reduced internal efficiency in exchange for survivability characteristics that Japanese designers had considered unnecessary. Commander Kiyoshi Inoue, assigned to lead the technical investigation, studied captured American damage control manuals with growing amazement. The documents described procedures that assumed catastrophic damage as a routine scenario, requiring methodical response rather than desperate improvisation. American crews trained for scenarios that Japanese sailors never imagined facing. Flooding, fire, structural collapse, power loss, and casualty evacuation were treated not as emergency situations, but as operational challenges with documented solutions. The organization of American damage control parties revealed sophisticated understanding of emergency response under combat conditions. Each section of an American carrier hosted dedicated repair teams, equipped with specialized tools, firefighting equipment, portable pumps, and emergency lighting. These teams trained continuously on damage scenarios, practicing responses until procedures became automatic reflexes. Japanese carriers, by contrast, relied on general crew assignments with minimal specialized training for damage control operations. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Material differences became apparent as investigators examined captured American firefighting equipment. American damage control teams employed fog nozzles that created water mist barriers more effective at controlling aviation fuel fires than traditional straight-stream approaches. Portable pumps could be deployed anywhere aboard ship, powered by independent gasoline engines that functioned even when main electrical systems failed. Japanese carriers lacked equivalent portable equipment, depending instead on fixed installations that became useless once power systems were damaged. The investigation into Yorktown's specific damage sequence revealed even more troubling insights. When Agusa's bombs penetrated the flight deck, They detonated in spaces containing aviation fuel, ammunition, and personnel. The resulting fires generated temperatures exceeding 1,800 degrees Fahrenheit, hot enough to compromise steel structural members. Yet, American damage control teams had contained these fires within 2 hours, using techniques that Japanese crews did not practice and equipment that Japanese carriers did not carry. Detailed analysis of American firefighting doctrine showed systematic differences in approach. Japanese damage control training emphasized immediate fire suppression using maximum water application. This created its own hazards, as excessive water accumulation increased list angles and risked capsizing damaged ships. American procedures prioritized containment over suppression, using fog barriers to prevent fire spread while carefully managing water application to maintain ship stability. The Americans had clearly studied damage scenarios with scientific rigor that Japanese training programs never attempted. The restoration of Yorktown's propulsion systems after catastrophic damage represented perhaps the most impressive accomplishment. 3 bomb hits had disabled all electrical power, silenced boilers, and knocked out primary engineering controls. Japanese engineering crews facing similar damage would have abandoned any hope of restoring propulsion capability. Yet Yorktown's engineers had repaired enough systems to generate partial power within 90 minutes, enabling the carrier to maneuver and conduct flight operations before the torpedo attack that finally sealed its fate. American engineering compartments featured backup control stations, redundant electrical distribution systems, and cross-connection capabilities that allowed undamaged boilers to power damaged sections. Japanese carriers lacked such redundancy, treating engineering spaces as unified systems rather than networks of interconnected but independent components. A single, major hit could disable Japanese carrier propulsion entirely, while American vessels maintained surprising capability even after multiple strikes. The investigation team reviewed reports from survivors of Japanese carriers sunk at Midway, seeking comparisons with American damage control performance. Akagi had been hit by a single bomb that penetrated its flight deck and detonated among armed and fueled aircraft in the hangar. The resulting fires proved uncontrollable despite desperate efforts by damage control parties. Within minutes, secondary explosions began detonating stored ordnance and aviation fuel. Captain Taijiro Aoki ordered abandonment after less than 3 hours of firefighting attempts. Yorktown, by contrast, had absorbed 3 bomb hits in similar locations, but had controlled resulting fires within 2 hours. The difference could not be attributed solely to luck or hit placement. American damage control parties had demonstrated systematic advantages in training, equipment, and procedures that Japanese crews simply did not possess. The disparity raised uncomfortable questions about fundamental assumptions underlying Japanese naval design and operations. Material science analysis revealed additional American advantages. Yorktown's internal bulkheads employed steel alloys with superior heat resistance compared to materials used in Japanese carrier construction. Electrical wiring used insulation that maintained integrity longer under fire conditions. Piping systems incorporated isolation valves at intervals that allowed damaged sections to be sealed without shutting down entire networks. These seemingly minor engineering details accumulated into significant survivability advantages during combat damage scenarios. The investigation documented American damage control equipment that Japanese carriers did not carry. Portable gasoline-powered generators provided emergency lighting in compartments where main power had failed. Handheld radios allowed damage control parties to coordinate without depending on ships' communication systems. Quick-acting patches could temporarily seal hull breaches, buying time for more permanent repairs. Oxygen-breathing apparatus protected firefighters entering smoke-filled spaces. Each piece of equipment represented capability that Japanese damage control teams lacked. Training differences emerged as perhaps the most significant factor separating American and Japanese damage control effectiveness. American sailors spent hundreds of hours in damage control drills that simulated realistic combat conditions. Teams practiced in smoke-filled compartments with emergency lighting, learning to function under stress while wearing breathing apparatus and fighting simulated fires. Japanese training programs, by comparison, devoted minimal time to damage control beyond basic firefighting procedures. The Americans had institutionalized damage control expertise through specialized training facilities at shore establishments. Recruits attended schools dedicated to firefighting, flooding control, and repair techniques before reporting to fleet assignments. Japanese naval training focused on combat operations and gunnery, treating damage control as secondary skill, requiring minimal specialized instruction. This fundamental difference in training philosophy produced crews with dramatically different capabilities when facing battle damage. Organizational doctrine revealed even more troubling contrasts. American carriers designated damage control as a primary mission equal in importance to combat operations. Officer career paths included damage control assignments that developed expertise throughout the chain of command. Japanese naval culture, focused intensely on offensive capability and fighting spirit, treated damage control as unglamorous necessity that received minimal command attention until emergency conditions demanded improvised response. By autumn of 1942, Abe's investigation team had compiled findings that challenged core assumptions about Japanese naval operations. American carriers possessed survivability characteristics that derived not from superior ship construction alone, but from comprehensive systems integrating design, equipment, training, and doctrine. Replicating these capabilities would require fundamental changes to Japanese carrier operations, changes that seemed increasingly impossible as the war's demands consumed available resources. The material requirements for American-style damage control exceeded Japan's production capacity even before considering wartime constraints. Portable pumps, fog nozzles, breathing apparatus, emergency generators, specialized firefighting chemicals, and thousands of other items represented manufacturing commitments that Japanese industry could not accommodate while simultaneously producing weapons, ammunition, and replacement aircraft. The Americans could equip their carriers with comprehensive damage control equipment because their industrial base treated such materiel as routine production items rather than specialized luxuries. Training infrastructure posed equally intractable challenges. Establishing shore facilities for realistic damage control instruction would require resources that Japan could not spare. Instructors with specialized expertise were needed throughout the fleet rather than concentrated in training commands. The time required to transform Japanese damage control capabilities through improved training would span years rather than months, assuming resources could even be allocated for such programs given more immediate operational demands. The investigation team's preliminary reports acknowledged these limitations with carefully understated language. They could document American damage control superiority with extensive technical detail, but they could not propose realistic implementation pathways for replicating observed capabilities. Japanese carriers would continue operating with damage control limitations that Midway had exposed with devastating clarity. Inoue's technical assessments included detailed analysis of specific Yorktown damage control actions that had prevented the carrier's loss during the initial bombing attack. When fires erupted in the forward part of the ship, American damage control parties had immediately established fog barriers that prevented flames from spreading to adjacent compartments. Portable pumps maintained pressure in firefighting mains even after main pumps lost power. Emergency lighting allowed crews to function in smoke-filled spaces that would have been impenetrably dark aboard Japanese carriers lacking portable generators. The restoration of Yorktown's aviation capabilities demonstrated organizational sophistication that Japanese carriers had never achieved. While damage control parties fought fires and contained flooding, separate teams cleared flight deck wreckage, repaired arresting gear, and restored refueling capability. American carriers treated battle damage as temporary disruption, requiring coordinated response across multiple specialties. Japanese carriers, lacking such organizational depth, struggled to conduct any operations once significant damage occurred. Intelligence reports about American damage control training revealed a systematic approach that began during initial construction. Workers building carriers received instruction in damage control principles, learning how design features supported survivability objectives. This integration of damage control awareness from construction through operations created shared understanding across entire organizations. Japanese shipbuilding focused on combat capability, treating damage control as maintenance function rather than core operational requirement. The material quality evident in American damage control equipment highlighted industrial advantages that extended beyond simple production capacity. Portable pumps used advanced materials that combined lightweight with durability under harsh conditions. Firefighting equipment incorporated engineering refinements that improved effectiveness while simplifying operation under stress. Japanese equipment, built with fewer resources and less sophisticated materials, proved heavier, less reliable, and more difficult to employ effectively during emergency conditions. By December 1942, the investigation team prepared final reports that would be distributed throughout the Imperial Japanese Navy's technical departments. The documents acknowledged American damage control superiority, while carefully avoiding explicit statements about Japanese inability to achieve comparable capabilities. The reports recommended improvements within existing constraints, modifications that might incrementally enhance damage control effectiveness without requiring wholesale redesign of carrier operations. Proposed modifications included increased stocks of portable firefighting equipment, enhanced training emphasis on damage scenarios, and improved compartmentalization in new carrier construction. These recommendations represented marginal improvements rather than fundamental transformations. The investigation team understood that replicating American damage control capabilities would require resources, industrial capacity, and training infrastructure that Japan simply did not possess under wartime conditions. The psychological impact on Japanese naval officers who studied the investigation findings proved more difficult to measure than technical specifications. Officers who had commanded carriers at Midway now understood that their ships had been fundamentally disadvantaged by design and training limitations that transcended tactical considerations. The realization that American carriers could survive damage that would destroy Japanese vessels created strategic implications that no amount of fighting spirit could overcome. Carrier losses at Midway had been attributed to tactical mistakes, unfortunate timing, and American advantages in intelligence. The damage control investigation revealed more systematic problems that tactical excellence could not address. Japanese carriers were inherently more vulnerable than American counterparts, not because of inferior construction quality, but due to design philosophy that prioritized offensive capability over survivability. This fundamental trade-off, embedded in carrier design decisions made years before the war, could not be reversed through operational adjustments or improved training. New carrier construction programs begun in 1942 incorporated some damage control improvements recommended by the investigation team. Increased compartmentalization, redundant systems, and improved firefighting equipment appeared in vessels like Taiho and Shinano. However, these modifications represented incremental improvements rather than wholesale adoption of American damage control philosophy. Resource constraints, construction priorities, and resistance to fundamental design changes limited the extent to which lessons from Yorktown's survival could be implemented in Japanese carrier operations. The investigation's findings circulated through Japanese naval technical departments, informing design decisions for carriers that would not enter service until 1944 or later. By that time, the strategic situation had deteriorated to the point where superior damage control capabilities could not alter operational outcomes. American industrial superiority had produced numerical advantages that overwhelmed tactical considerations. Japanese carriers, regardless of damage control improvements, faced opponents who could afford to lose ships and rapidly replace them with new construction. Senior officers who reviewed the investigation reports understood the strategic implications. American carriers survived battle damage that would destroy Japanese vessels, returned to service after repairs that Japanese shipyards could not accomplish, and operated with crew training standards that Japanese naval education could not replicate. These advantages compounded over time, creating an attrition dynamic that favored the side with superior survivability rather than the side with superior fighting spirit. The investigation team documented one final insight that had profound implications for Japanese naval strategy. American damage control superiority derived not from secret technologies or mysterious capabilities, but from systematic application of engineering principles, comprehensive training programs, and industrial capacity to provide necessary equipment. Japanese naval architects understood these principles. Japanese engineers could design equivalent systems. What Japan lacked was not knowledge but implementation capability. The industrial infrastructure necessary to equip carriers with comprehensive damage control systems did not exist within the Japanese Empire. Manufacturing capacity was allocated to weapons production, aircraft construction, and replacement of combat losses. Portable pumps, breathing apparatus, and specialized firefighting equipment represented production commitments that could not be accommodated without reducing output of items deemed more immediately essential for combat operations. Training infrastructure faced similar constraints. Shore facilities for damage control instruction competed with immediate needs for pilot training, gunnery schools, and technical specialist programs. Instructors capable of teaching advanced damage control techniques were needed aboard operational carriers rather than training establishments. The time required to transform Japanese naval culture's approach to damage control through systematic training programs extended beyond any realistic time frame given wartime operational demands. By spring of 1943, the investigation into American damage control capabilities had concluded with findings that informed Japanese naval operations while simultaneously documenting limitations that could not be overcome. Officers understood that their carriers remained more vulnerable than American counterparts. Designers incorporated improvements that marginally enhanced survivability without fundamentally altering the strategic balance. Crews received enhanced training within constraints imposed by operational demands and resource limitations. Yorktown's survival of 3 direct bomb hits had revealed systematic American advantages that transcended individual incidents or tactical considerations. The carrier had remained afloat not through luck or exceptional individual performance, but because American naval architecture, training programs, equipment procurement, and operational doctrine treated damage control as core capability, requiring comprehensive integration throughout entire organizations. Japanese carriers, built within different constraints and operated under different assumptions, could not match these capabilities without fundamental transformations that wartime conditions made impossible. The investigation team's final reports included technical appendices describing specific American damage control procedures, equipment specifications, and training methodologies. These documents circulated through Japanese naval technical departments, informing design decisions and training programs for the remainder of the war. However, the fundamental conclusion remained unchanged. American carriers possessed survivability advantages that derived from industrial capacity, training infrastructure, and organizational doctrine that Japanese forces could observe, analyze, and document, but could not replicate under existing conditions. Inou's personal notes, discovered after the war, reflected on the psychological burden of documenting national limitations with scientific precision. The investigation had revealed that Japanese carriers entered combat with inherent disadvantages that courage and tactical skill could not overcome. This knowledge created moral obligations to pursue improvements, while simultaneously acknowledging that meaningful improvements remained beyond reach given wartime resource constraints and strategic priorities. The summer of 1943 brought additional confirmation of American damage control superiority. Carriers damaged at the Battle of the Eastern Solomons returned to Pearl Harbor for repairs that restored full combat capability. USS Enterprise, hit multiple times during the Guadalcanal campaign, underwent repairs that Japanese shipyards could not have accomplished and returned to frontline service within months. Each incident reinforced patterns documented in the Yorktown investigation, demonstrating that superior damage control represented systemic American advantage rather than isolated capability. Japanese carriers continued suffering disproportionate losses when damaged in combat. Shokaku and Zuikaku required months of repair after relatively minor battle damage at the Battle of the Coral Sea. Junyo and Hyo proved similarly vulnerable to damage that American carriers routinely survived and quickly repaired. The pattern reflected fundamental differences in design philosophy, training standards, and industrial support that the investigation had documented in exhaustive detail. By 1944, as American forces advanced across the Pacific, the strategic implications of damage control superiority had become undeniable. American carrier task forces operated with confidence that damaged ships could be saved, repaired, and returned to combat. Japanese carrier operations accepted that significant damage would likely result in total loss regardless of crew efforts. This psychological difference influenced tactical decisions, with Japanese commanders understanding that their carriers represented irreplaceable assets, while American counterparts viewed losses as temporary setbacks. The Battle of the Philippine Sea in June 1944 demonstrated these dynamics with devastating clarity. Japanese carriers Taiho and Shokaku suffered submarine torpedo hits that would have been survivable aboard American vessels with proper damage control. Instead, both carriers exploded and sank due to aviation fuel vapor accumulation that American damage control procedures would have prevented. The losses eliminated Japanese carrier aviation as effective fighting force, not because of inferior aircraft or pilots, but due to damage control failures that American crews would have contained. Post-war analysis confirmed that the investigation team's findings had accurately assessed American damage control capabilities. United States Navy damage control schools had trained tens of thousands of sailors in specialized techniques that Japanese forces never systematically implemented. Equipment stockpiles aboard American carriers included comprehensive inventories of portable pumps, breathing apparatus, firefighting chemicals, and emergency repair materials that Japanese vessels could not accommodate due to production and storage limitations. The investigation's legacy extended beyond wartime operations into post-war reconstruction of Japanese naval capabilities. Officers who had studied American damage control practices became advocates for implementing similar systems in post-war maritime vessels. The knowledge gained through analysis of Yorktown's survival influenced Japanese shipbuilding practices for decades, contributing to development of merchant marine and naval forces with damage control capabilities that previous generations had considered impossible to achieve. Surviving investigation reports, preserved in naval archives and eventually declassified, provided historians with unique insights into how technological disparity influenced Pacific War outcomes. The documents revealed that Japanese naval officers understood American advantages with remarkable clarity while simultaneously recognizing their inability to match observed capabilities under wartime constraints. This knowledge without implementation capacity created psychological burdens that survivors carried throughout their post-war careers. The investigation into Yorktown's damage control performance represented one of the most comprehensive analyses of enemy capabilities conducted during World War II. Japanese engineers had correctly identified design principles, training methodologies, and equipment specifications that enabled American carriers to survive damage that would destroy Japanese vessels. Their documentation proved technically accurate and strategically meaningless, providing knowledge that could inform but not transform Japanese naval operations under existing conditions. Commander Tanabe, whose torpedoes had finally sent Yorktown to the bottom after 30 hours of survival that should have been impossible, never learned the full extent of what his observation had revealed. The carrier that refused to sink had embodied systematic advantages in design, training, equipment, and doctrine that transcended individual incidents. Yorktown's survival demonstrated that modern naval warfare required not just fighting ships, but comprehensive industrial and training infrastructure to keep those ships fighting after battle damage occurred. The investigation team's final conclusion, stated with characteristic Japanese understatement, acknowledged that American damage control superiority represented a strategic advantage that tactical excellence alone could not overcome. It was a deceptively simple assessment, free of dramatic language, yet behind the reserved tone lay an uncomfortable recognition, almost a reluctant confession. Japan's carriers, magnificent in many ways and crewed by some of the finest aviators in the world, could fight with unmatched zeal and artistry in the skies, but once bomb blasts tore through steel decks and ignited aviation fuel, their fate was often sealed. Tactical brilliance was no substitute for better steel, superior ship design, or a meticulous doctrine of survival. The findings were quietly circulated among senior naval officers and ship designers. In a culture that valued stoicism and perseverance, admitting that the enemy had built sturdier ships and trained their crews to save them under hellish circumstances was difficult. Yet the investigators did not disguise their observations. American carriers were built not just to fight, but to survive. Japanese carriers, elegant and daring, had been engineered foremost for offensive power. The difference was philosophical as much as technical. The United States Navy had grown up expecting to operate across vast oceans. Its logistical doctrine emphasized sustainability as much as striking force. From the earliest sketches of the Yorktown and Essex class carriers, American designers prioritized compartmentalization, redundant systems, and the ability to contain and isolate damage. Fire suppression equipment was abundant, and more importantly, damage control was a discipline treated with the same respect as gunnery or flight operations. Crews trained for it, drilled for it, and even competed in it. Sailors were expected to fight fires, repair ruptured pipes, seal flooded compartments, and improvise life-saving measures when machinery failed, and do so under combat conditions. By contrast, Japanese naval strategy had been shaped by a different set of expectations. Japanese carriers were instruments of initiative, swift, powerful, and designed to knock out enemy forces in decisive, sudden blows. The Imperial Japanese Navy believed in striking hard and striking first, but little attention was given to what would happen after being struck. Ships were often built with minimal armor in critical locations, flight decks were thinner, and hangars were open, connected spaces more susceptible to catastrophic fuel and ordnance explosions. Most importantly, damage control was seen as an afterthought, something to be handled reactively, not proactively. These truths were never fully hidden, but they became painfully undeniable after the Battle of Midway. When the Americans hit Akagi, Kaga, Soru, and Hairu, they did not just destroy the ships with bombs, they destroyed them because those ships could not protect themselves once damaged. Fires turned hangar decks into infernos, aviation gasoline ran in burning rivers, and bomb shards ignited stored ordnance that should never have been exposed to such risks. Japanese commanders reported their ships lost not simply to bombs, but to uncontrollable post-strike disasters. The investigation team reviewing the Yorktown incident saw a different pattern. Yorktown, though hit hard, did not die. She had been caught unexpectedly, hammered by dive bombers, and later struck by torpedoes. On paper, her wounds were mortal. Yet she refused to sink, at least, not immediately. Her crew fought back not with guns, but with hoses, pumps, welding torches, ropes, steel plates, anything they could use to plug a hole or smother a fire. Damage control teams moved with precision, almost choreography, across tilted decks and smoke-filled passageways. Their training had been so relentless that when chaos arrived, they responded with practiced calm. The Japanese investigation concluded that Yorktown survived her initial damage because she was designed to survive and because she was manned by sailors trained to fight for their ship's life. The psychological impact of this realization was profound. To win future battles, naval officers understood they would need not just better pilots, but better ships, better training, and better ways to keep ships alive after being hit. But the conclusions prompted by the Yorktown report were subtle, quietly stated, and perhaps, too, understated to evoke urgency. Japanese carriers would continue fighting with courage and skill, but they would do so knowing that their ships remained fundamentally more vulnerable than their American counterparts. This knowledge informed later operational planning, but it did so as a grim acknowledgement rather than a catalyst for transformation. Strategists adjusted tactics, suggesting that Japanese carrier forces should avoid prolonged engagements and prioritize striking power over endurance. They recommended increased emphasis on surprise attacks and cautioned against situations where Japanese ships might be caught in sustained battles of attrition. There was an understanding that if losses took time to develop, as with slowly spreading fires or flooding, Japanese carriers were at higher risk than American ones. Their ships could deliver crushing blows, but could not withstand them. As the war dragged on, these vulnerabilities manifested themselves repeatedly. At the Battle of the Coral Sea, Shoho died quickly, almost too quickly, her thin hull and lack of internal safeguards, making her little more than a floating ammunition crate once bombs began to fall. At Santa Cruz, Shokaku took heavy damage, but somehow survived, though barely, and only because American bombs had missed key fuel tanks by sheer chance. At the Philippine Sea, Japanese carriers largely avoided damage because they were outmatched in the air, their air wings depleted, their crews inexperienced. But by then, their ability to strike back had evaporated with their training programs. Then, at Leyte Gulf, the tragedy of Japanese carrier vulnerability became final and symbolic. Zuikaku, the last survivor of the Pearl Harbor strike force, fought bravely but fatally weakened. Her decks burned, her escape routes choked with smoke, her pumps failed, and her men, courageous and committed though they were, could not save her. Chitose, Chiyoda, Zueho, all died violently, not merely because they were struck, but because they could not keep fighting after being struck. By war's end, the lessons documented in the early investigation reports had been learned repeatedly, not from manuals or lectures, but through bitter, irreplaceable loss. Japanese carriers that might have survived with proper damage control instead became total losses. Crews that lacked training, proper equipment, and organizational support faced impossible challenges when battle damage occurred. They had discipline, bravery, and patriotism, but without the tools and doctrine to survive catastrophic damage, they were fighting fires with bare hands and unprotected lungs. Perhaps most haunting of all, the investigation into Yorktown's survival had predicted these outcomes with uncomfortable accuracy. What had seemed at first like a singular event, one carrier's stubborn refusal to sink, had, over time, become a symbolic illustration of two fundamentally different philosophies of war. The Americans believed ships were worth saving, and they trained to save them. The Japanese believed ships existed to strike, and to strike gloriously, even if that meant accepting their frailty. There was also a cultural dimension, quiet but influential. The Japanese naval tradition honored bravery, precision, and sacrifice. The idea that a ship might fight for its own survival, not as a weapon but as an organism, a living thing worth preserving, was less ingrained. American sailors took personal responsibility for every inch of their ship. They saw damage control not merely as a duty, but as a way of protecting their home, their crewmates, their identity. Many of them later said, "We were not going to let our ship die." That sentiment, while universal in spirit, had more institutional reinforcement in one navy than the other. In the post-war years, naval engineers and historians would look back at these findings with the clarity of hindsight. They saw the irony. The Imperial Japanese Navy had started the war with arguably the finest aviators, the boldest operational thinkers, and the most aggressive doctrine. They had, for a brief time, dominated the Pacific skies. But the United States Navy, whose pilots were initially less experienced and whose tactics were still evolving, built carriers that could endure even when overwhelmed. And in the end, it was endurance, not just initial striking power, that won the war. The understated report that had followed the Yorktown incident remained archived, rarely quoted in speeches or ceremonies. It was not glamorous or inspiring, but in its quiet language, it told a truth that proved decisive, even final. Once a ship is struck, its survival depends not on courage alone, but on preparation, design, and doctrine. Victory in naval warfare was not only about hitting the enemy, it was about surviving the hit. Up next, we have two more incredible stories that are waiting for you. Just click the image you want to watch, and it will take you there. If you enjoyed this video, make sure to subscribe. It would mean a lot.